Algebra 2, 3.3c, we're going to find the domain of a function. Now, I mentioned this in the last video, but this is for people who don't normally watch my videos. When you see these numbers, that means we're at Chapter 3, the third lesson, and we're in C, that part of the lesson. It's the third part of Lesson 3. So that means there were two videos before this one. And if you haven't seen them, you can click on this video's description and go right to those, 3.3a and 3.3b. And if you haven't seen the previous videos for Chapter 3, you might get confused, okay? So you can find those in this video's description also. So here we go. When the function in R cross R, that's real numbers cross real numbers, is given by a formula, we understand the domain is all real numbers that are acceptable replacements that'll make the function true. So that means we can make ordered pairs out of every real number crossed with every real number. That's quite a list, isn't it? And because the domain x is part of the definition of a function, changing the domain is going to change the function. If the domain is the set of positive integers, okay, so that's not 0 and it's not negatives. So if the domain is a set of positive integers less than 4, then the function defined by y equals 4 divided by x is going to be this set. If we have 1 for x, then 4 divided by 1 is going to be a 4. Y will be a 4. And if x is a 2, then 4 divided by 2 is a 2, so y will be a 2. And if 4 is divided by 3, because see, it's 1, 2, 3, or 4. All right? Then it's 1.333, so I put the bar over the top. All right? So if it was less than 4, then this one wouldn't count, would it? Because it has to be less than 4. So this one's not in that group, really, is it? Okay? But when the domain is the set of all real numbers, then the function consists of an infinite amount of ordered pairs. They're way too long to list. We can't list every single ordered pair of real numbers with real numbers. That would take forever. So I'll show you what we're going to do, all right? So just bear with me. So what is the domain of f for the function of x equals x minus 4 divided by x plus 3? Well, to find the domain of f, we need to see if there's any unacceptable replacements. So what would be unacceptable for x to be? Well, what happens if x is a negative 3? What if we have negative 3 plus 3 here? That would make a 0, wouldn't it? And that's undefined, and we can't divide by 0. So it can't be a negative 3. The function of negative 3 would make a 0 down here for the denominator. And since we can't divide by 0, the replacement negative 3 is not acceptable. And when a replacement is not acceptable, that number is not in the domain of the function. So it's not included. Now, if you're confused about it being undefined, you need to go back to video 1.2c in this Algebra 2 playlist. Go to this description, go to the Algebra 2 playlist link, and scroll to 1.2c about division that's undefined, okay? And then that'll clear that up, all right? So, as I said, when a replacement is not acceptable, like that negative 3, that number's not in the domain of the function. So the domain of f for the function of x equals x minus 4 divided by x plus 3, we write the answer, the solution, as the set of all x such that x is not equal to negative 3. So any value for x is okay as long as it's not a negative 3. That's the one value that it can't be. And because there's so many other possible values, it's easier to just say which one it's not, okay? So I want you to look at it this way. If you own every color shirt in existence except red, and someone said, what color shirts did you own? It's easier to list the colors you don't have because that's just one, see? So that's what we're doing. We're saying what it's not. All right, so it says find the domain of the function h of x is equal to 2x divided by x minus 6. Well, we can just look at this denominator and know that a positive 6, well, that would make a 0 pair, and division by 0 is undefined. So if we had 6 minus 6, that would make a 0 here again, and it would be undefined, right? So what's not allowed is a 6. So h of x is equal to x such that x is not 6. See? All the other ones are okay. The denominator holds the answer to the number that'll make a 0. So you'll know what to put in here by what's going to make a 0 in the fraction. See? When you see it like this as a fraction, you could do it really quick because you just have to see what's going to make that 0, and that's the one that's not allowed, and you can write it in set builder notation. See? How about what is the domain of the function f of x equals the absolute value of 4x minus 2? Well, what it's asking is, for the function of x, what can x equal if y is equal to some number times x? Because remember, it's just x and y. This function of x is basically the y, see? So what number could y be times some number that x is that would fit in here? See? What can x equal if y is some number times x? Well, if we put a 2 in there and we say 4 times 2, well, that's 8 minus 2. That's a 6. So if x is a 2, which we put here, that means that x is a 2. See? So that means that's got to be a 3 to make 3 times 2 to make that 6, right? So the function of x is a 6. And our ordered pair is x is 2, function of x is 6, or y is 6. See? We could also say the domain is R, because x can equal all the real numbers. See? So the answer to what is the domain of the function f of x equals the absolute value 4x minus 2, the answer is the domain is all real numbers. Because every number we put in here for x is going to work. Okay? The domain is the set of all numbers we can input without creating an impossible situation. And when there's too many possible answers to list, it's easier to list the non-answers. Well, in this case, there are no non-answers. Every real number would fit in here for x. So the domain is R. It's all real numbers. Okay? Now, if you're still confused, I want you to remember what I wrote here, that f of x is actually y. Okay? Got my little chart up here. Y is the range, the output, the y coordinate. It's the function of x. It's the second set of members in an ordered pair relation. It's the ordinate. And x is the domain, the input, the x coordinate, the set of first members in a relation in an ordered pair. It's the abscissa. Okay? So, knowing that the f of x is basically just the y, if we had f of x equals 2x, it's like saying y equals 2x. The only difference is we have to multiply some number by what x is. See? X is on both sides. If we plug a 1 in for x, then we get that the f of x is 2. If we plug a 2 in as x, then we get the f of x is 4. See? And because this is such a basic function, it's all real numbers. Y can be all real numbers. The function of x can be all real numbers. It could even be 0. See? X is the input variable, and f of x creates the y. It uses the x to create the y. See? All right? Boy, I hope that made sense to you. All right, so our next video is 3.4a, and we're going to talk about how to recognize linear equations, and we're going to talk about equations in the first degree. If you want to go to this description, you can click on the Algebra II playlist to do any reviewing that you need to do if you have tests coming up. It's an easy way to study. Just sit back and listen and watch. There's also going to be links to my graph and linear equations chapter playlist from Algebra 1 and the relations and functions playlist from Algebra 1. And there's quite a bit that we talk about in Algebra 1 that we talk about in Algebra 2. So that could be helpful if you've forgotten what we did last year. Okay? All right. So I will see you next video, and we'll start with lesson 4 with 3.4a. Bye.